Special thanks to Lazarus Maldonado for providing us with today's MSM Draw. Submit a drawing prompt with the hashtag MSM Draw in this video for a chance for it to be drawn in the next one. Hello everyone, and welcome back to the Cretanium channel. We unite once again for a new edition of Monster Biology, and today we're going to be spinning the Magicals wheel. To be honest, I'm intrigued on how to explain most of these monsters, as they don't seem to conform to standard biology found in the real world. I especially look forward to talking about the whimsies in a future video, but for now, let's spin. Woo! We get to know what Spytrap looks like! The very first thing I want to clarify is the fact that, according to the game, the name Spytrap refers to the plant part of the monster. The resident inside the bulb has no official name. Feel free to come up with your own species name in the comments, but for now, I'll call it a spydrum. It looks spidery, it drums, and it implies that the plant catches these monsters in particular to give it the name Spytrap. With that out of the way, I'd like to mention that this episode focuses specifically on the Spytrap, because the spydrum doesn't seem to have any important characteristics besides bioluminescent eyes. These are most likely due to the glow of Light Island reflecting off the tapetum lucidum, which is a special membrane inside of the spydrum's eyes that allows it to see in the darkness. It's worth noting that the wolf spider and its relatives possess this membrane as well. Man, we just started and I've already went off on a tangent. Let's start our examination of the Spytrap now. Now, if you ask me, the Spytrap doesn't look like your stereotypical plant. There are no green leaves for photosynthesis. Its skin looks thick and notched like an elephant's. As per the bio, it can also reason and negotiate, although in a world with actual sentient plants, that doesn't matter as much. The Spytrap seems more animal than plant, so I've illustrated it as a mixture of the two, a planimal, if you will. Thus, it has a central nervous system and muscles, but structured in such a way that it resembles the inside of a plant. If we were to take a cross-section of the Spytrap's neck stem thing, we would find that it has a thick and grayish epidermis. This serves to protect the inside layers and is loaded with nerve receptors. Moving inwards, we would find what, in a plant, would be the cork. It would most likely be a substance that stores nutrients like fat and provides internal structure like cork. Past the cork fat is the circulatory system, which consists of multiple large veins and arteries running the length of the Spytrap. They transport blood up and down the stem like xylem and phloem do in plants, and they transport water and nutrients. In place of a heart, the Spytrap would have periodically spaced aortic arches like in an earthworm. They function essentially as hearts, but their positioning up the stem of the Spytrap guarantees that blood can make it all the way up to the bulb. The next layer is a cross between the spine of an animal and the pith of a plant. It gives more support to the heavy bulb and flexes under the weight to keep the stem from snapping in half. Finally, at the very center is the nervous system. Instead of a brain, this monster possesses a central nervous cord running the length of the body with spaced out ganglia, which are clumps of nerve cells that act like tiny brains. This gives the Spytrap enough sapience to regulate body functions and respond to stimuli. The rest of the Spytrap's body continues underground and ends in a worm-like tail that anchors the organism in place. The next feature to look at is the musculature of the Spytrap. Don't you find it interesting that the monster has those differently colored bumps on its skin? Different explanations include skin tumors and plant-like burls, which are deformed cell growths caused by stress. But the conical protrusions around the bulb of the Spytrap, combined with the proposed internal anatomy, lead me to believe that these are little pockets of muscle. The Spytrap would need a great deal of musculature around the bulb membranes to open and close them. The lumps on its body could be muscles to move the stem. When the muscles of one lump contract, it pulls the rest of the body like this. It's like how biceps are located on a human's arm. They're a lump positioned on the cylindrical shape of the arm and contract to pull the rest of the limb up with it. A fact that supports this observation is the fact that the skin over these muscles appear redder than the rest of the body, an indication of increased blood flow into the muscles. Okay, so now we can get to the good stuff and talk about the relationship between the Spytrap and the Spydrum. The pair exhibit a mutual relationship where the actions of each benefit the other. According to the bio, the Spytrap benefits from the companionship while the Spydrum gets fed. Switching gears, it's quite probable that the Spytrap relies upon the vibrations the Spydrum makes when it initially approaches. It would be able to sense them through its skin underground. With that given, we can examine two ways the Spytrap could initially ensnare its companion. Firstly, the Spytrap could lure in the Spydrum with its bioluminescent bulb. Much like a moth to a flame, the Spydrum would approach the glowing bulb and get snapped up. I think this explanation is not likely compared to the other one that I'm going to talk about, mainly because we never see the Spytrap lighting up its bulb on its own. It's always at the strikes of the Spydrum. This leads me to believe that the bioluminescence of the Spytrap's leaves are an interesting side effect. Many animals can bioluminesce due to a chemical called luciferase, mixing with another catalyst within their cells. Phytoplankton glow when they are disturbed, so it can be inferred that a punch to the inside of a Spytrap's bulb produces a little ring of light. However, this color is a reddish pink, which has some interesting connotations. The stoplight loose-jawed dragonfish, which is an awesome name, can produce a red light to be able to see its surroundings. The thing is, not a lot of animals can see red light, so the dragonfish can identify potential meals without its prey ever realizing that it's in the spotlight. So this red light the Spytrap creates could possibly be a private signal to other Spytrap. It could mean that it caught a Spydrum, and is inviting the other Spytrap over in case another one comes by. Or adversely, it could be saying, "Stay away," to the other Spytrap. Because it caught a Spydrum, it doesn't want any competition in the area for when it grows and reproduces. The Spydrums would be oblivious to these hidden messages because they wouldn't be able to see in the red spectrum. Just imagine how a valley populated with Spytrap would look like at night. The other way a Spytrap could catch its partner is through the sweet sap it produces as per the bio. It could drip a little fragrant sap on the ground, and when the Spydrum catches a whiff and comes over to sample it, snap! This seems more likely than the Spytrap attracting the Spydrum with light, because I just talked about the fact that Spydrums wouldn't be able to see red. So let's talk a little bit more about the Spytrap's sap. The bio states that the Spytrap feeds the Spydrum with a steady drip of sap. This implies that the sap is produced and descends down into the Spydrum's mouth. The most logical place to put the source of this sap is in the top of the bulb. Those little dangly doodads are called trichomes, and they are found in different plant species like the sundew. The sundew is a carnivorous plant that produces a sap from the ends of its trichomes, which are tipped with special mucus glands. When an insect lands on the sundew's leaf to eat the sap, the sundew's trichomes wrap around it and dissolve it. In the monster world, it works slightly differently. Much like the sundews, the trichomes of the Spytrap produce mucus-like nectar, which hang over the Spydrum's head. The Spydrum then hits the inside of the bulb to dislodge the sap and eat it. The Spydrum obviously benefits from this relationship because it gets a home and free food. But how does the Spytrap prosper from this relationship? The answer, like so many in monster biology, can be found in real life. Enter the plant family Viridula, also known as the flycatcher bushes. Much like the sundew, the plant's leaves are a sticky death trap for insects. All insects except the assassin bug. This insect makes its home on the flycatcher bush and is immune to the sticky sap due to its naturally greasy exoskeleton. Think trying to stick duct tape onto a pepperoni pizza. Oh, that doesn't help very much, does it? When an insect becomes ensnared by the sap, the assassin bug walks over and eats it. When the insect that was eaten eventually makes its way out the other end of the assassin bug, if you know what I mean, the plant absorbs it. Studies show that the prey insects that are processed, for lack of a more dignified term, by the assassin bug are able to sustain the flycatcher bush more efficiently. So, let's adapt this to my singing monsters. In short, the Spytrap catches the Spydrum, who eats the sap. In return, the Spytrap eats its droppings. Oh, that doesn't sound like a fair relationship, does it? The flesh petals of the Spytrap would be able to secrete a digestive enzyme that clears away the refuse of the Spydrum. This makes sense because most carnivorous plants grow in poor soil conditions and need another type of food to sustain themselves. The fact that Spytrap grows in the sodden skin of a warty titan only strengthens this theory. And I think that we're done. Hit it. Rare and epic time! Watch this. The rare version of Spytrap would most likely have minor sprite edits. A recolor, a couple of spikes, who knows. The Spydrum would probably retain its 4 arms because the monster handlers often don't change the means with which the monsters make its sound. It could have some extra vestigial limbs or something. I noticed that Spytrap looks like Gob, so maybe the rare could expand upon that relationship. You can't really predict what an epic monster can look like, so extreme are the visual changes. One of my commenters, AT, said that the epic Spytrap should be a moth and a lantern, and I agree wholeheartedly. What an awesome idea! When creating an epic, it should be known that the primary sprite will always be redrawn, and Lantern Spytrap fits nicely into that philosophy. Another idea would be a bubble Spytrap, perhaps a big blue bubble Spytrap, that clearly shows the canon design for the Spydrum. So yeah, those are my thoughts on the rare and epic Spytrap. Let me know what you think. I'm very happy with the overall content of this episode, very informative. So as always, thank you for watching the Creeptanium channel, and I will see you all later.